Okay, welcome grade 10s. We're now starting a new section of our unit on quadratic formulas and quadratic equations. What we're now looking at is the last of the three forms of quadratic equations. So there's three forms: standard, factored, and vertex. If we think back, we've so far looked at standard and factored. Standard form is our y equals ax squared plus bx plus c, where we have the C clearly visible, which is our y-intercept, and the A tells us what the direction of opening is. So if A is greater than 0, it's going to open up, and if A is less than 0, it's going to open down. The other form we have is the factor form, which is y equals A bracket x minus r bracket x minus s end bracket. So the A once again indicates the direction of opening. And the r and the s are our zeros, so where the parabola goes through the x-intercept, the x-axis to give us our x-intercepts. And from our zeros, we can find the axis of symmetry and our vertex. The last form that we're going to be discussing, which is the whole point of this lesson, is vertex form. So an example of an equation written in vertex form is y equals 2 bracket x plus 3 and bracket squared plus 8. So the general form of the equation is going to be this: y equals a bracket x minus h and bracket to the power of 2 plus k. If you notice, the name is vertex form, so you can probably guess that this is going to show us the vertex of the parabola from the equation. In this case, how we're going to find it is the h and the k are part of the vertex. So we have the h here coming from inside the bracket. That's going to be our x value of our vertex, and the k is our y value of the vertex. And once again, our a shows us the direction of opening, either positive or negative. So let's break this down a little bit more. So the coordinates of the vertex are h and k, which come from our vertex form. The direction of opening is indicated by the sign of A. Our horizontal shift, aka our h, is the equation for the axis of symmetry. We'll talk more about the horizontal shift, what that means, in a later lesson, but for now, just focus on the h. And the k is the vertical, not life, vertical shift. So if k is equal to 0, the vertex is going to be on the x-axis, meaning that there's only one root, one x-intercept, 1, 0. Remember, x-intercept, root, and 0 all mean the same thing. If k is positive, but a is negative, the graph is going to be above the axis and opening down, so that's going to give us 2 intercepts. Now, if k is negative, but a is positive, the graph is going to open below the x-axis and open up, meaning there's going to be 2 intercepts. So if you're noticing here, if these signs are opposite of each other, we're going to have 2 intercepts. But if the k and the a are the same sign, so positive and positive or negative and negative, there's going to be no intercepts or zeros. So let's see what we can find from a quadratic relation. Let's apply this. So we're going to look at these equations and state the vertex, find the equation for the axis of symmetry, state whether the direction of the parabola is opening up or down, and state the number of zeros. So looking at the first one, remember our vertex is the h and the k. So here's our h, and here's our k. In this case, we're going to take the opposite sign of the h value here. So if it's negative 3, when we write it in the vertex, we're going to have it the opposite sign. So it's going to be now a positive 3. So in this case, our vertex, looking at -2 bracket x minus 3 bracket squared plus 2, our vertex is going to be that +3 and the +2, which is our k, and that is our y of our vertex. B is asking us to find the equation for the axis of symmetry. Now, our equation for the axis of symmetry has always been the x value of our vertex. So we can now say that it is just that x equals 3, because our x value of our vertex is 3, so therefore our equation for the axis of symmetry is 3. State the direction of opening. In this case, we have a -2, and the negative tells us it's going to open down. D, state the number of zeros. So remember the hint that I was telling you is if the A and the K are opposite values, we're going to have 2. So if we look at here, we have a -2 and a +2. These are opposite, so that means we're going to have 2 zeros, or x-intercepts, or roots, all of them meaning the exact same thing. So we're going to look at this one here. The next one, we have 2 bracket x plus 3 bracket squared. We're missing a k value. So if the k value is not here, it's going to be a 0. Looking at our vertex, we're going to take the opposite sign of the h. So in this case, it's +3, so that means we're going to have -3. There is no k, so that means it's going to be a 0. Our axis of symmetry is the x value of our intercept, of our vertex, and so that's going to be x equals -3. We look at our A for our direction of opening. It's positive, so therefore it's going to open up. And we don't have a k value, so that means that our zeros, we're just going to have 1 because it's going to be, our parabola is going to be sitting on the x-axis. So we have 1, 0. Let's graph these two. The third one's going to be on the lesson that's posted in Google Classroom. You can check that out there. So when we're graphing this, what we're going to do here is we're going to quickly add some little lines here so we can have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we're going to first start off by plotting our wonderful vertex, which is at 3 and 2. So we've got 3, go up to 2, it's going to be around here. Now, something new that we haven't really talked about is the step theory of quadratics. So the step theory of quadratics is how far over you're going to move from each point as you go. It's represented by A, 3A, and 5A, and 7A, 9A, 11A. It just keeps going as we go. You add 2 to each. The A is the value in front of the parabola. So this A value would be replaced. So if we're looking at this guy, how we're going to move down is we go down 2, then -6, then -10 points. And you move from the previous number. So if we're looking at this one here, I'm going to switch. We're going to look at the next point. So we're at 2, 3 and 2 here. Our next point is going to be over 1, down 2, which brings us here. The next one, if we had space, we would go over 1, and from the that point, we would go down 6 spots. We'll have practice with this more in a minute. So that's what this graph would kind of look like. Not the greatest, but we're there. Now looking at this one, same idea. Let's plot some of these points in. Five, 1, 2, 3, 4, 5. Okay. So we're going to plot first our intercept, our vertex, which is at 3 and 0. And in this case, when we're looking at our things, we have A, 2A, 3A, 5A. So our next point, since it's multiplied by 2, would be 2, 6, and 10. We go over 1, up 2, over 1, up 2. Again, if we had more space, we'd go up 6 from this point. When you look online, you'll have the answers visible for this one here. But for sake of time, we're going to move on to the next point. Right now, what we have here is an equation in vertex form. What we want to do is move from vertex form to standard form. How we're going to do that is by multiplying this out. Now, one of the things that I want you guys to really remember is that you don't directly bring the square root straight into the brackets. What this really looks like is x plus 4 end bracket times by x plus 4 end bracket minus 2. From here, we do FOIL. It's really important that you guys remember these steps properly for future reference. So what we're going to do is we do the first bracket, so x times x, x squared. Outside, x times 4, so plus 4x. Inside, 4 times x, so plus 4x. Last, 4 times 4, plus 16. And we still have that minus 2. We're going to bring all of our information together. We get x squared plus 8x plus 14. And now we've just gone from vertex form to standard form. Next part here is an example where we're given information and we need to find the vertex form. So we have the vertex of the parabola is -5 plus 3. And the parabola passes through the point -2 and -15. Determine the equation of the quadratic relation in vertex form. So let's start off by writing out our vertex form. We have y equals a bracket x minus h squared plus k. We're going to bring in the information we know. From our parabola here, we know that the x value of our vertex is -5. That is our h. So we're going to replace our h with that number. So bracket -5. And our k value is our 3, so plus 3. Next up, we're going to bring everything together. So we have x, the negative, and negative becomes a positive, so we get plus 5 squared plus 3. Now, we still have an unknown variable here. We have a. What we're going to do is take this point and sub it in for x and y. So we get -15 equals a bracket. We're going to replace our x with -2 plus 5 squared plus 3. Next, we're going to start collecting like terms. So we're going to get -15 minus 3. We have a bracket. -2 plus 5 equals 3 squared. Next line, we get 18. 3 times 3 gets us 9, so it's 9a. We divide both sides by 9. That should be -18. And we get -2 equals a. So what we're going to do is now write out our full equation with everything that we know. So we have therefore y equals -2 bracket x plus 5 squared plus 3. And that is our vertex form. So we started by putting in the vertex into the formula, collected it. Then we took our other point so we could find out what A equals. We solved for A. And then we brought it all together in the final point. So that is our true answer here. Alrighty, and let's look at couple more examples here. So in this one, we have a parabola has zeros of -4 and 2, and it passes through a point 3 and 4. So here's our 314. Here's our important part. So we have a 0, we have a point. Find the vertex of the parabola and write the equation of the quadratic relation. So first, what we want to do is find what our parabola is in vertex form. So how we're going to do, sorry, not in vertex form, in factor form. So we're going to start by writing out what our factor form should look like. So we have y equals a bracket x minus r, x minus s. So in this case, we have our r and our s, which are two zeros. We're going to bring those into the equation. So we have y equals x minus 2, x minus -4. Next line, we're going to bring that all together. So we got y equals a, x minus 2, x plus 4. Next, we need to find what our a is. So we're going to sub in our points here to find and solve for a. So we get 14 equals a bracket 3 minus 2 bracket 3 plus 4. So we get 14 equals a times y. That's 3 minus 1. Sorry, 3 minus 2 gives us 1. 3 plus 4 gives us 7. So we're going to get 7a equals 14. Divide both sides by 7. And our a equals 2. So let's bring this equation back together. Our equation right now in factor form is 2 bracket x minus 2, x plus 4. Okay, so we have our equation. Next, what we're going to do is find our AOS. And our AOS is x equals our two zeros added together. Just write this out a little bit better. Bracket -4. Divide by 2. 2 minus 4 gives us -2 over 2, which gives us -1. Now that we have our AOS, what we need to do is find our y. So y equals 2 bracket. We're going to sub in our AOS, which is -1. We're going to subtract 2. Again, we place this x with our -1 plus 4 end bracket. So we get 2 times by -3 times by +3. 3 times -3 gives us -9. 9 times by -9 times by 2 gives us -18. So therefore, our vertex is -1 and -18. So what we're going to do now is bring all this information together in our vertex form. So remember, our vertex form is y equals a bracket x minus h squared plus k. So this is our h, -1 from our vertex, and our y value of our vertex is our k. So let's start plugging that in. We also know that our a is 2 from our other equation. So we have y equals 2 bracket x minus -1 squared minus 18. We're going to bring it all together now. We have y equals 2 bracket x plus 1 squared minus 18. And that right there is our vertex form. So those are our steps. First, we create our lovely version of our factored form. Then we find our AOS. Then we find our y value of the vertex. And then we take our vertex and place the h and the k and the a into our vertex form. Next one, find the y-intercept for the quadratic relation. So we have 3 forms. The current form it's in is vertex form, which tells us our vertex and our a. The other 2 forms we have are our standard form and our factored form. Our factored form tells us our a, our direction of opening, and our zeros. We don't want that. Our standard form, however, tells us what our y-intercept is in that c value. So what we're wanting to do here is expand our vertex form into standard form in order to find what our y-intercept is. So let's start that. Y equals -0.5 bracket x minus 6 power of 2 minus 5. So what we're going to do now is start off by expanding and then foiling out this square. So let's expand it out. X minus 6 bracket x minus 6. We're still subtracting 5 at the end. So what we have here is -0.5 and bracket. We do the first, x times x, that gives us x squared. X times -6 gives us -6x. The inside -6 times by x gives us -6. -6 times -6 gives us positive 36. And bracket minus 5. Collect the terms in the bracket. So we get x squared minus 12x plus 36 minus 5. Next step is to bring this -0.5 into the entire bracket. We're going to distribute it in. So when we distribute it in, we get -0.5 x squared. -0.5 times by -12x gives us positive 6x. -0.5 times by positive 36 gives us -18. And we still subtract the 5. And let's bring the last part together. -0.5x squared plus 6x. -18 minus 5 gives us -23. This value right here, the -23, this is our y-intercept. Here's our c value, and that is our y-intercept. So we can have our little therefore. Therefore, the y-intercept is -23. What you guys can do now is work on the in-class practice as well as the assigned work. All the answers will be posted up online in the document, as well as that one missing question that we didn't do just in this recorded lesson. If you guys have any questions as you're doing the homework, as always, put a star next to it, and in the next class, be sure to ask where you're having trouble with so we can go over it as a class. Have a good day, guys.